All right, let's start. So this is just the continuation of what we have discussed last time. So this was taken from the book Engineering Differential Equations by Bravo, Cruz, and Gomez. So this is number 8, 9, and 10 dun sa libro. So let's answer this figure. So sabi dito sa figure, we are looking for the current in ampere through the inductor as a function of time t. So kung gagamit tayo ng mesh analysis for a while. So when this switch is closed, so meron akong current loop there and another loop here. So dalawa. So meron tayong I1 at saka I2. So as you can see, kung ita-traverse natin yung loop na to, merong current na magpo-flow in this particular circuit. And then traversing this loop, meron tayong current na magpo-flow dito as named I2. So since ang gagamitin natin ay, or this mesh analysis is just a extension of Kirchhoff voltage law, then di ba pag sinabi nating KVL, ang pinag-uusapan natin ay voltage, that's a force. So pag force ang pinag-uusapan, so yung voltage na naiaano nito, na ipupush nito, say force 1, which is actually voltage na ng current 1 ang sinasabi ko dito, voltage ng current 1 ay ino-oppose ng voltage nitong current 2. So let's say force 2. So di ba para makuha natin ang resultant force, so dapat kung opposing lang sila, so kailangan kunin ko lang yung difference nung dalawa, tapos I will follow kung anong whichever the direction nung mas, let's name it as RF. So kukunin lang natin yung direction kung ano yung mas malakas na voltahe. So kung i-represent natin yung voltage across the inductor, so that's VL is equal to LdI dt. So since dalawang current ang nag-uumpugan dito, so this is equal to L, derivative of the difference between those currents with respect to T. So ang VL natin is a more complicated one, di1 dt minus L di2 dt. So as you can see, dalawa ang ating dependent variables na isosolve, kaya medyo mahihirapan tayo dito kung ito yung gagamitin natin. So pwede natin siyang padaliin. So how are we going to do that? So kung babalikan natin ang principle ng parallel circuits, so palitan ko lang. We know that voltage across this 2 Henry inductor is equal to the voltage across this 15 ohm resistor. So, kahit pagpalitin ko ng posisyon yung dalawa, hindi mababago ang aking circuit. Say, for example, I have here 10 ohm. Gagawin ko itong 15 ohm resistor connected to the ground. And then you have here an inductor connected to the ground. So, that's 2 Henry. So, since parehas lang ang voltage dito, so kahit pagpalitin ko lang ng pwesto yung dalawa, parang hindi mo na rin ginalaw ito. So, kumbaga, nag-addition property of equality tayo. So, parang hindi rin nabago since same lang naman yung, hindi mo na alter totally yung circuit mo or yung behavior or yung relationship between the parameters dito sa mga involved dito sa ating circuit. So, kung gagawin natin yan, mas mapapadali. So, I'll show you kung bakit. So, palitan muna natin. So, para mas ma-analyze natin. So, again, gagawin natin tong resistor. So, this will be our 15 ohm resistor. And this will be our 2 Henry inductor. So, pag in-analyze natin, so again, let's switch this on. May loop I1, loop I2. So, by KVL, so, syempre, nag-start tayo sa ating source 10 volts. So, yung voltage drop natin dito, that's I1, R1. So, let's name this as R1. Let's name this as R2. minus I1 R2, yung current 1 dito rin. And since merong current 2 na nag-o-oppose dito, so i-add natin yung opposition niya, which is I2 R2 is equal to 0. So E here minus I1 times the quantity, the sum of the two resistors, if you factor out I1, plus I2 R2 is equal to 0. E is 100 minus I1, the sum of resistances 10 and 15, that is 25, plus 15 I2 is equal to 0. So simplifying by transposing this negative 25 I1 to the right side and then 15 I2 to the right side of the equation gives 25 I1 minus 15 I2 is equal to 100. This can be simplified by dividing it all by 5. So that's 5 I1. Wait, ayaw sumulat. Purahin ko siya. Ayaw niya sumulat eh. So dividing by 5 ulit. So that's 5 I1 minus 3 I2 is equal to divide 5, 20. So this will be our equation 1. So kunin natin yung KVL at I2. So this is negative I2 R2. Yung I2 R2 natin dito. And it is being opposed by I1 R2. Then minus voltage across this inductor. So that's LDI 2 dt. So yung current na nagva-vary dito ay yung current 2 kasi yun yung nagfo-flow dito. So derivative of I2 with respect to t is equal to 0. So but R2 is 15. So this is 15 I1 minus 15 I2 equals, transposing this LDI dt, sa right side magiging 2 derivative of I2 with respect to t. So notice na yung kanina, nung hindi natin pinalitan, dalawa ang ating dependent. Nung pinalitan natin, pinagpalit natin yung pwesto, iisa na lang ang ating dependent, which is actually the current 2, which is actually our unknown parameter. So, hindi na tayo mahihirapan kasi diretso na, pag nasolve na natin ito, kung differential equation na ito, yun na kaagad ang ating sagot. So now, since ang dependent variable natin dito ay I2, so dapat all the rest must be expressed in I2. So since meron ako ritong I1, so I will use equation 1 para mapalitan ko ito in terms of I2. So again, from equation 1, we have 5I1 equals 3I2 plus 20 by transposing that negative 3I2 sa right side of the equation. So I need 15I1. So since meron ako ritong 5I1, to make this 15, I need to multiply this by 3. So that magiging na siyang 15I1 is equal to 9I2 plus 60. And that 15I1 be replaced with this 15I1, which is equal to 9I2 plus 60. Substituting 9I2 plus 60 minus 15I2 is equal to derivative I2 dt. So this 9I2 minus 15I2 is negative 6I2 transposed to the right becomes positive 6. So this gives you 2 derivative I2 dt plus yung transpose natin kasi this is negative 6I2 transposed to the right becomes positive 6I2 equals 60. So dividing this all by 2 gives derivative of I2 with respect to t plus 3I2 equals 30. So this will be our working differential equation. So now, masosolve natin iyan. So let me just rewrite derivative I2 dt plus I2 times 3 is equal to 30. So now to find the IF, so since this is FODE, linear DE, so this is method 7. So integrating factor e raised to integral of 3 dt, yung coefficient natin ng ating dependent variable. So that's e raised to 3t. And imumultiply natin siya sa ating differential equation given e raised to 3t to make this left side of the equation be equal to derivative of our dependent I2 and ating integrating factor. So that's 30 e to the 3t. To solve for this equation, since exact na siya, integrate na natin siya with respect to t. So to integrate that, I need to satisfy my du here. If u is 3t, ang derivative niya ay 3 dt, so I need to provide 1/3 outside. So this integral and derivative cancels out. You have I2 e to the 3t equals 10 e to the 3t plus our arbitrary constant k. Since 30 divided by 3 is 10, e to the 3t plus k. Solve for I2, multiplying this all by e to the negative 3t, e to the negative 3t to cancel this e to the positive 3t. So that's 10 plus k e to the minus 3t ampere. So since ito yung ating general solution, ang hinahanap ay initial current. So at time t is 0, wala tayong current, so I2 is 0. So substituting, 0 is equal to 10 plus k e to the 0. Or negative 3 times 0 is still 0. Then k here is negative 10. So therefore, I2 is equal to 10 minus 10 e to the minus 3t. Or, simplifying, that's 10 times the quantity 1 minus e to the minus 3t ampere. So such I2 is the current through the inductor at any function time t is this letter A. So, if ever na may binigay sa atin na value ng find the current at t is equal to 3 milliseconds. So, sa-substitute lang natin doon kasi nakuha na natin yung equation ng current natin through the inductor at any time t. So, what is the final value? Paano natin malalaman ang final value? So, when t approaches infinity. So, again, the current is equal to just 10 ampere. Kasi di ba pagka when t approaches infinity, this becomes 0. So 10 times 1 is 10 amperes. So this must be our final value. Okay, so let's proceed with the next. So in circuit figure 3.14, so ito rin yun, 3.14, meron siyang follow-up question. What is the current in the 15 ohm resistor at any time? So, hanapin natin yung current passing through this R2. So, di ba, yung current na nandyan ay dinidefine ni I1 at saka ni I2. So, ang tanong, ano daw yung I15 na pinag-o-opposa nitong dalawang ito? So, from this circuit, again, principle ng parallel circuit, voltage across this resistor 2 is equal to voltage across the inductor. So, from there, makakakuha tayo ng relationship, VR2 is equal to VL. So, VR2, gamit ang Ohm's law, that's I15 multiplied by R, that's VIR, V is equal to IR, so current through the 15 ohm resistor, multiplied by R2, is VL, which is L, derivative of I2 with respect to T. Then I in 15 ohm resistor is equal to L over R times the derivative with respect to T of what we have solved I2 here. So that's 10 minus 10 e to the minus 3t. So substituting 10 minus 10 e to the minus 3t gives I15 is equal to L, that's 2 Henry, over resistor 2 is 15 times the derivative with respect to t of this one. So, tanggalin ko na ito kasi pwede ko na kunin ang derivative. So, what must be the derivative? So, the derivative of 10 is 0. Derivative of negative 10 e to the negative 3t is negative 10 e to the negative 3t times the derivative of negative 3t, which is negative 3. So I15 here is equal to 2 over 15 times 30 e to the negative 3t, because negative 3 times negative 10 is positive 30. Then I15 ohms is equal to 4 e to the minus 3t ampere. Because this 30 divided by 15 is 2 times 2, 4. So you have here as your final answer. Qutable. Okay, so let's proceed sa last example natin sa transient. So in figure 3.15, find the initial current through the capacitor. So again, ito naman yung kinukuha nating current. So again, kung may loop 1 dito, may current 1, may current 2 na na-oppose. So kung ganon, ang VC natin is given by Q over C. So since dalawang current ang nag-uumpugan, that is Q1 minus Q2 over C. So since meron tayong dalawang current. So para maiwasan ulit natin yung mahiwagang dalawang variables na yan, pwede nating pagpalitan. Pagpalitin, I mean. Pagpalitin. So this will be my resistor, 75 ohms. And then this will be my capacitor, 1 millifarad. So analyze natin using mesh analysis or in extension of Kirchhoff voltage law. So at I1, that's E minus I1 multiplied by R1 plus R2. That's what we have derived kanina. Yung ito, R1 plus R2. Yung I1 tsaka yung R2 dito. R1 plus R2. And then plus yung inoppose ni I2. So that's plus I2 R2 is equal to 0. So E is 90 minus I1 multiplied by R1 is 25 plus 75 is 100 plus I2 multiplied by 75 is equal to 0. So transposing this negative there and this positive there gives 100 I1 minus 75 I2 is equal to 90. Dividing it all by 5, which is our greatest common, by 5, that's 20 I1 minus 15 I2 equals 18. So this will serve as our equation 1. Equation 2 agad, excited. Equation 1. At I2, so that is negative I2 multiplied by R2 plus opposing I1 R2 minus Q over C para sa voltage across this capacitor. And since I2 lang yung tumadaloy dito, lagyan natin ng subscript Q2 equals 0. So R2 is 75. So 75 I1 minus 75 I2 is equal to, transposing it there, Q2 over 1 times 10 to the negative 3. That's 75 I1 minus 75 I2 equals 1,000 Q2. Because 10 to the negative 3, pag inangat, magiging 10 to the third, that is 1,000. So dividing it all by 25. So divide natin siya by 25. So this gives 3I1 minus 3I2 is 25, 104, 40 Q2. So this will be my equation 2. So since Q2 ito na related kay I2, tatanggalin natin si I1. So using equation 1, again from equation 1, that's 20 I1 equals 15 I2 plus 18. So let us divide it all by 20. I1 is 15 divided by 20 is 3/4 I2 plus 18 divided by 20 is 9 over 10. So replacing I1 there, so that's 3, quantity 3/4 I2 plus 9 over 10 minus 3I2 is equal to 40 Q2. Simplifying gives 9/4 I2 plus 27 over 10, because 3 times 9 there is 27, over 10 minus 3I2 is 40 Q2. Combining like terms, you have 4 9/4 here and negative 3 here. So that's 9/4 minus 3I2 plus 27 over 10. It's not 27I. It must be 27 over 10. Equals 40 Q2. So this is negative 3/4. Transposed to the right becomes 27 over 10 equals 40 Q2 plus 3/4 I2. But I2 is dQ2 dt. So this gives us 3/4 dQ2 dt plus 40 Q2 is equal to 27 over 10. So kailangan ma-isolate natin ito. So multiply tayo ng 4/3 both sides. That's dQ2 dt plus Q2 times 4/3 times 40 is 160/3 equals, this cancels out with 9/5/2. That's 18/5. So this will be our LDE of dependent Q2. So what's my IF? IF is e raised to integral of the coefficient of our dependent variable with respect to t, e to the 163rd t. So such integrating factor again must be multiplied to our LDE, which is e raised to 163rd to make our equation exact. So to make that exact, that's derivative of Q2 e to the 163rd t equals 18 over 5 e to the 163rd of t. So, para mawala yung derivative, i-integrate natin siya. Integral of derivative of Q2 e raised to 163rd t equals 18 over 5 e to the 163rd t dt. So pag in-integrate natin, satisfying du, I need to provide that 160 over 3 and 3 over 160. That integral and derivative cancels out, gives us Q2 e to the 163rd of t equals, by 2, you have 980. So 3 times 9 is 27 over 400 e to the 163rd of t plus our k. So to solve for Q2, i-multiply natin siya with e to the negative 163rd of t. That's 27 over 400 plus k e to the negative 163rd of t. Again, at time t is 0, q is 0. Kasi it's not stated in our problem. Substituting, you have 0 equals 27 over 400 plus k e to the 0. Then k is negative 27 over 400. Negative 27 over 400. Then Q2 now is equal to 27 over 400 minus 27 over 400 e to the negative 60 over 3 t coulomb. That is the equation of the charge in the capacitor at any time t. But since ang hinahanap is current, we need to take the derivative with respect to t of that Q2. So taking the derivative with respect to t of 27 over 400 minus 27 over 400 e to the negative 60 over 3t is equal to, derivative of that is 0. That's negative 27 over 400 e to the negative 160 thirds times negative 160 over 3. Hala, di kasya. Pagkasyahin natin siya. Ulit. Kakasya yan. Negative 27 over 400 e to the minus 160 over 3t multiplied by negative 160 over 3. What is I2 now? Paki-calculate naman. This times that. 27. That's 9. 1. Pag 8. Pag 60, cancel yung 60. Pag 8, may 5 dito. May 2 doon. That's 18 over 5. E to the negative 160 thirds of t. Ampere. So, ang tinatanong ay initial current. So, that is at time t is equal to 0. So, substituting at time t is 0, I2 is 18 over 5 e to the 0 ampere. So, therefore, I2 is simply 18 over 5 ampere, which is actually equal to 3.6. So, this will be our answer. End ko lang ang recording.